In this video, I'll illustrate how to set up confidence interval for the case the population variances are equal. The sigma sub 1 squared is equal to sigma sub 2 squared. Same problem as before. Population 1 is DRP scores for third graders who participate in the specially designed reading activities, and population 2 is third graders who do not participate in the reading activities. So we are interested in 95% confidence interval for mu sub 1 minus mu sub 2. We've already developed the data analysis output when we did the hypothesis testing previously. Okay, let me show you that result. So up here, so we did a test for the equal variance case, and this is the output where we do have the pooled variance estimate right here. So we'll use the results from this problem for the confidence interval down here. So first, let's get the pooled variance estimate from above, and then sample sizes for the two cases. So sample size is the third row right here, and we'll copy that to control group. So we have n sub 1 and n sub 2. Next, we set up standard error. So standard error is this formula: S sub p times square root of 1 over n sub 1 plus 1 over n sub 2. So here we have the pooled variance estimate. This is S sub p squared. So we need to start with first taking a square root of that. Okay, that would be our S sub p times square root of 1 over n sub 1 plus 1 over n sub 2. That will give us the standard error, and our confidence level is 95%. That's our 1 minus alpha. So if you do 1 minus that, that will give us the alpha value. Degrees of freedom, we'll get it from the data analysis output, which is right here, B79. The t table value then is t dot inv dot 2t. The alpha value, comma, degrees of freedom, that will give us the t table value. Now, so we have the standard error, we have the t table value. Now we need x bar sub 1 minus x bar sub 2. That is the third part. We'll get that from the data analysis output. So that's your x bar sub 1 minus x bar sub 2. So now margin of error is t table times standard error. Now we have everything we need. So the lower limit is x bar sub 1 minus x bar sub 2 minus the margin of error, then x bar sub 1, x bar sub 2 plus margin of error will give us the confidence interval upper and lower limits. So the interpretation will follow the same interpretation as the confidence interval that we did before. So I'm going to just simply copy that interpretation down here and make the necessary changes. So we are 95% confidence that the difference in the DRP scores between the students who took the test, who took the reading activities, and those who did not, so that will be now between 1.09 and 18.82. So the interval is slightly wider in this case. That's because the underlying assumption that we just made, that the two standard deviations sigma sub 1 and sigma sub 2 are equal, that assumption is probably not valid. That's the reason why we are ending up with a larger confidence interval.